Hello everyone. This is our research on hand gesture recognition on mobile phones using deep learning method. Hand gestures are one of the ways that enables intuitive and natural means of connection and interaction between human and computer interaction, sign language, virtual reality, computer vision, etc. In this research, we improve the interaction using air gestures. We want the interaction to facilitate our job with phones, computer, and make it efficient and work faster, saving time. In this research, we implemented deep learning models to our mobile phone, which uses RGB cameras. The reason in doing so is because of the generality. We want our model to work in every Android devices. However, there are many drawbacks and complexities in doing so. Deep learning requires powerful computational resource, memory storage, which apparently mobile phones lack. Also, variability of the image background and illumination variation causes a lot of problems to get a good result. So we propose a new way of overcoming those difficulties and have an efficient and real-time gesture recognition model that works naturally. The figure shows the overview of the method we use. And gesture recognition has been tackled by wearable sensors and vision sensors to identify static or dynamic gestures. And vision sensors, which is available in every kind of electronic devices, and they are user-friendly. Since vision sensors can be used in generalized situation and everyday life. Before people use different kind of algorithm to do research. Recently, deep learning models have achieved great success in a wide range of computer vision tasks. The success of deep learning has motivated researchers to develop hand gesture system based on deep learning algorithms. Even if many research have been done, there is not that much work regarding on the mobile environment, because if we take into account the limited computational resource of smartphone, it eliminates bunch of options that the deep learning model getting the advantage of. Therefore, usage of RGB camera is the best option for the implementation of deep learning. Compensation between accuracy, computational burden, or not having vision accessory except RGB cameras leads to high challenging tasks such as the variability complexity of the image, background ethnicity, color differences, shadows, and other illumination variation, and they become major problems. In this work, we decided to overcome some of these mentioned difficulties and have efficient and real-time working hand gesture recognition model for the mobile environment by adopting HGRNet method of recognition. And by doing so, we want to implement it in a mobile phone environment.
Methods and procedure. We had initially adopted the HRNet full as itself in order to check whether the model works or not. In this figure, we have shown the picture of the model. As you can see, the model is composed of two stages. In the first stage, it does the segmentation, and the second stage does the classification. And what does use for the segmentation is residual groups and ASPP. And the second stage uses CNN. And how it works is that it has two streams, and first stream takes the input from the first stage, which is segmentation map, and the second stream uses the raw pure or RGB image. Due to lack of offered code sources and lack of extensive understanding on deep learning itself, we had a hard time to implement the actual code on our device and make the model succeed. Thus, the only way to overcome the situation was to develop our own model, referring to the powerful method and optimal idea the authors of HRNet used for the case like ours, which combines segmentation and RGB image itself to train the model and includes two streams of CNN for the classification, as we discussed earlier. The method also consists of two-stage architecture as an HRNet, and the first stage we adopted the algorithm that works on HSV values of the hand region, segments the raw image in real time. The algorithm has two phases: color calculator, where the skin is determined, and the hand detection, where the hand signal is analyzed. And algorithm also uses the Gaussian blur as highly effective in removing Gaussian noise and is not really heavy. However, the edges are blurred a little bit in this operation. In the second stage of the model, we predict the hand gestural ability using the fusion of the two streams in the same architecture as in the HRNet. Which is basically taking the RGB image and the segmentation map and learning from that. The main advantage of the two-stage architecture is that it uses the RGB image for the robust recognition of the and detection of the hand gestures. Here in the figure, in the table, we've given the architecture of the CNN model. Two streams. In the blue part is the CNN, and which use convolution and max pooling. And in the end, the two streams are concatenated or fusion using the fusion function. After passing through some layers, it has been predicted by using softmax classifier. So since we're not using deep learning model for the segmentation stage, the attempt model had one advantage compared to the HRNet. It takes up very much less computational power and memory. However, they performed segmentation, got the following results using which is trained by Ohans dataset. As you can see from the figure, there is represented class number with the red number on the left corner, the 1. As you can see, all of them are classified as class 1, which is actually obviously not. And we conjectured that the reason for that is classification. And as you can see from this figure, the top row represents the segmentation from the HRNet, and the second row represents our segmentation model. And as you can see, our segmentation model cannot segmentate well compared to the other one. And therefore, we had to modify the segmentation algorithm to another method, segmenting the hand from an image. So we adopted simpler algorithm which works on super background and there's constant variation and particular lightning. The reason why we adopted the algorithm was that it's easy to implement for anyone, and the source code is publicly available. The algorithm is OpenCV and an open source library, therefore it's much cheaper than any technique in terms of computation and size. And in the RGB input has been grayscale using CVT color and reduced the noise of the image, and blur was applied, and most commonly used technique threshold has been applied. And here we can see the segmented image and classified part. As you can see, again, the classification couldn't do well because it's showing the red numbers as a class number 1. Therefore, we had to come up with a new method now. And this is our proposing method, the last method. Therefore, and so after not getting a good accuracies, we developed our final classification model, fairly similar to classification part of the HRNet model, and retrained it again with the same Johans dataset, which that we have used initially. Our structure is similar to HRNet. And that was intentionally done in order to mimic the effective methods of HRNet for the hand recognition. Our model also contains 2 stages, where in the first stage is to segmentate of the hand, and in the second stage we do classification. The first stage, named the segmentation stage, adopts end-to-end source and publicly available machine learning platform TensorFlow image segmentation model. In the classification stage, we use streams of CNN used in order to predict the image containing hand gestures using of separate CNNs. And architecture is given as below, and you can see convolutions and poolings, and there's global average pooling and the dropout and 2 dense layers.
We use OU-Hand dataset which contain 10 different hand gestures from 23 subjects, split into training with 2,000 and 1,000 images respectively, which came with image segmentation maps. To compare, we adopted one of the best deep learning models, which is MobileNet, developed for mobile platforms. And we can see the comparison below of our and MobileNet. And as you can see, our model gives the best accuracy and F-score among those state-of-art methods. However, its heavy parameters and size compensate them. We initially felt that up, but got inspired by it. Our model has roughly similar attitude in recognizing hand gestures. More surprisingly, our model overpassed the famous ResNet 50 and DenseNet 121 model, which gave the highest accuracy and F-score. We can see that in the below table. And we represented the visual results of our segmentation model, and utilizing that segmentation map, how exactly the classification model can predict the given hand gesture. As you can see from the figure, the model got correct prediction in classifying the images and the segmentation pretty much accurately in the real-time background. To challenge the accuracy of the model, we tried the same gestures in dim light, where it might have hard to recognize the hand due to lighting variation. And you can see from the figure, the prediction is completely correct, even though the segmentation was not that good. And lastly, we checked our model on mobile platform. To do that, we use Redmi 7 with Android version 9, RAM 3 GB, and CPU octa-core Max 180. And this is the best result we have got so far.
As a conclusion, We adopted HRNet learning model to implement on mobile platforms. At first, we tried HRNet itself without any adjustments, as the model hasn't been implemented on the mobile environment platform before. Then, as we didn't succeed in achieving these results, we developed our own model and inspired by the original HRNet architecture. The created model had also two stages, where in this first stage we used HSV values of the Hanskin, and in the second stage we conserved the classification of the part of the HRNet. However, the model couldn't predict class levels well, and we may consider the reason for it is not having proper segmentation method. Therefore, we use simple algorithms, which use only RGB values and OpenCV library of Python. Then we realized that the classification model wasn't working as well, since the new segmenting algorithm gave us sharp images, hence overriding our initial conjecture. So in the end, we trained the classification model after some modifications, mostly imitating the HRNet classification structure, and used TensorFlow image segmentation for our first stage. And here is our references. Thank you very much.